So today we are starting with the Java messaging service, and let me see. So today we are starting with Java messaging service. So basically, first we are going to deal with the architecture of the JMS, and then we'll go over how to configure queues and topics on the application server. Okay, so let's move ahead fast. So JMS stands for Java Messaging Service, and Java Messaging Service is a part of API specification, which is given by the J2E standard. So the Java Enterprise Standard specification, which is there, JMS is part of that particular specification, and it is about sending messages to and fro from one location to the other, right? So just for a second, let's forget that we have web services into picture, and these days even the web services support asynchronous communication. So web services, the JAX WS specification supports asynchronous web services, but that was not always the case. Plus, web services is also a new entry into the game. So before that, say if you have to communicate between two systems, the messaging service was into play. Okay, so the messaging service was there from long time, and it was earlier supported by actively, and IBM is a major vendor here. It had its MQ product, IBM MQ message queuing product, and it is very robust product. It's used along with mainframes also, and even from the other Java J2 applications, you can connect to this MQ and can download messages. So this is a very robust system which has been in place for a long time. So on the top of that system, JMS was developed as a specification and was made as a part of the J2E standard. Okay, so JMS follows what has been in vogue, that is in fashion, in practice for last several years in the case of Java messaging service. So the thing is that, say if you get some messages, if you want to communicate between two systems, like say two mainframe systems, one way to do is, and very common way to do is, that you send a message to that particular system, and that message communicates to the downloads that message, and it works on it. So this is a messaging service system, and it's like very useful in the sense that you can send messages, you can persist it there, you can make sure that the message is not destroyed. If the message is downloaded, you can work on it. You can only download the message and not remove from the queue. So various services are there. So you can send messages from one place to the other place, and then communicate information and then get a response. So it is a very good method to do that. Okay. So Java Messaging Service API is a part of the Java Enterprise Edition specification. JMS is all about sending and receiving messages between two or more clients. It is a specification that describes a method by which Java programs to create, send and receive messages. So now if you come and try to see what JMS service may mean as part of J2 standard, is that from your end or from our end, what we need to do is to call certain APIs, right? To call certain Java programs, certain methods. But in turn, the framework which has been developed as part of the J2 standard, that takes care of the actual transmission of the message from one location to the other location. Alright, that's how it works. Now let's go below. So JMS API enables communication that is loosely coupled and messaging that is asynchronous in nature. So these are two very important things, and I was saying that nowadays even web services supported, but that was not the case earlier, right? And even today, for mainframe to support web services, there are multiple things which has to be done. As far as you know, there is a kick API which has to be enabled, etc. So if you want to communicate between, say, two different systems, say mainframes and the Java application, then it's difficult, because to send a web service request from the mainframe side, you have to do a lot of you have to enable a new set of APIs called Kicks API and then work on it. So I don't think so. It's very straightforward, and the usual practice till now has been to send a message on a message queue, and then even the Java application can download messages from the queue and can look into it. So now if you see these the systems which are involved in this, the example which I gave right now, the mainframe system and and the Java application, they're not like very tightly coupled. They're independent. They don't have any relationship with each other. The only communication which happens between them is through this message queue. So mainframe system sends a message to the message queue, and the Java application downloads a message from the message queue, right? And the messaging itself is asynchronous in nature, in the sense that it's not that the Java application waits for the messages to come. It does its own work and maybe periodically checks the messaging queue. And even the mainframe application is not like dying to send the message on the queue, right? It's not its only job. It's doing whatever it has to do, and whenever required, it drops a message on the queue. So in this way, the messaging is asynchronous. It's not like uh, once a message is sent to the queue, you are waiting to get the response, right? I mean, that might not be the case. Although you can implement you can implement synchronous messaging also, but by default it is asynchronous in nature. So as soon as you drop a message, I mean, that's it. I mean, you need not look into anything more, right? So that's how the JMS API. These are the advantages of the JMS APIs, and even messaging service in general. I mean, this has nothing to whatever I explained right now has nothing to do specific with the J part of the JMS. Even any messaging service, it's built on any platform, any language. I mean, they all follow the standards which has been set by the earlier MQ product, which has been there in the market, the IBM MQ, and basically all of them are loosely coupled. The applications which are involved in this communication is loosely coupled, and the messaging is asynchronous in nature. So there are two important things which enable the communication between two disparate systems. Okay. Now, if we come below and see, like in a typical architecture, what are the important participants, right? So in any kind of architecture, you have participants like things or blocks or systems which do something. So in the case of JMS architecture, also we are expecting something, right? So one is JMS provider, a messaging system that implements the JMS specification. Okay, that is JMS provider. So JMS provider is a messaging system that implements the JMS specification. So basically, it implements the JMS specification and sends the messages on the queue, right? So that is a JMS provider. Now JMS client is something which is a messaging system that implements the JMS specification. And JMS clients is something. There are two types of clients. One is like producers, publisher, something which like this is the client. Here it creates and sends the messages, and then you have consumer, subscriber. This is a client which basically receives the messages. So you have like JMS provider. So JMS provider basically, in the example which I was giving earlier, IBM MQ is sort of JMS provider. So active MQ provided by Sun Systems is a JMS provider. It's basically the framework, someone who has provided this messaging system to work on. And the client is both. I mean, the one which creates the messages and the one which consumes the messages. They both are types of clients. So the one which creates the messages are called as JMS producers or publishers, and the one which consumes are known as JMS consumer or subscribers, right? And whatever we send from the producer side to the consumer side, that is the message, right? And that particular message might be in a particular format depending on what is the requirement, but there is no strict format out there for that particular part. And then you have administered objects, so pre-configured JMS objects that are created by an administrator for the use of JMS client. So this is like some internal objects which are created. We do not typically work on it. So these objects are isolated from the proprietary technology providers. This helps in JMS clients portability. Anyways, now let's come to some of the MM service providers. That is message-oriented middleware service providers. So different messaging systems have to be in place. One of the common ones which is talking about is this one, IBM MQ series. It is a very, very famous one. In fact, most of the enterprises which are there for a long time, like say many banks, Bank of America, and many systems which are there for a long time, they all have been using IBM MQ series. One of the things with IBM MQ series is it's very, very, very robust. I've never experienced myself any problems with this particular MQ series, and it's very straightforward the working with it. The only thing is that it's proprietary and it's paid product, so it's not like you can download it and start working on it. There is some licensing cost associated with it, so that's why, I mean, it's not that, I mean, I can develop any application on it or you can develop any application on it, but typically this is a preferred product in the case of enterprises because it has proved its versatility over a period of years. And frankly speaking, there have been applications where I had the choice of using, like say, even the IBM MQ series, they support JMS specifications. So JMS was built the IBM MQ series has its own set of APIs, and then there are JMS APIs. So JMS APIs actually then call the IBM MQ series APIs, and they actually do the work. Or you have otherwise have the option of directly going and contacting the IBM MQ series API and getting the work done. So this integration between the JMS APIs and the IBM MQ APIs, that is not very smooth. I mean, we had problems in the past where we were not able to send messages properly. The encryption was not working properly, and at the end we decided that why not go ahead and use the IBM MQ APIs directly. But anyways, that might be a problem with the specification or the way in which the encoding etc. is done. However, the point which I want to bring here is that the MQ series APIs and the MQ series itself has been around in the industry for a long time and is one of the very very stable products. The second one which I want to discuss here was ActiveMQ. Now Apache, as you might know, has come with a number of things which you can use for your use, such as Tomcat is one of the products, very famous products from the Apache. And then these days even NoSQL databases such as Cassandra etc. is supported by Apache. And ActiveMQ is another such product which Apache has built as a typical replacement for the messaging systems, ActiveMQ. And till now I have not seen it getting much use in the industry, but obviously on a smaller scale it's a much useful thing to be used. And we will also see an example, I think so, for ActiveMQ. Okay, so ActiveMQ is also one of the good products. I have not seen it getting used in the industry that much. Okay, so basically I've seen MQ series getting used a lot more. And second one was is the JMS the queues etc., which comes along with the Glassfish server, right? So the Glassfish service provided by Sun, which is basically Oracle, but that is not from WebLogic, because WebLogic is one of the paid products, right? So Sun had started with one of the servers, Glassfish, and in fact it was a free server, free application server, and it was used by many of the enterprises. I mean, they migrated to it after like shunning IBM application servers because of the cost associated with maintaining IBM application servers. So that's how the shift began, and the Glassfish started getting used even in the production environment. And it had its own share of challenges, as any new application server would have, but it definitely had its benefits as well, and it saved a lot of cost upfront. And then there are obviously maintenance costs, and then there are some things for which the application service for which you pay the licensing cost is much better. But anyways, let's not go there. So let's concentrate on the topics. One of the important is IBM MQ series. The second one is ActiveMQ. The third one is the Glassfish, which I was talking about. And Oracle's paid product, WebLogic, is also there. JMS also has this JMS MQ. Then there is a company called Progress. They have this Sonic MQ. Then you have TIPCO. TIPCO has its own messaging service. So these are some of the common and popular MMM service providers. Okay, so let's pause here and see what exactly, I mean, I think you should have understood by now, but let's draw a diagram and see whether you have understood exactly how the messaging flows or not. Okay, so the thing is that you have, like say, producer, okay, and the producer creates a message, right? And now this message, maybe say a form of an XML, say something of say customer, and then you have maybe just the first name and some value, and then that ends, right? So and then it ends. So this is a message. Now you have to send this message over to a queue. So you have a message queue in between, right? Or a topic, but let's not go there. But for now, just assume that a message queue. Now this message queue is sort of, again, I mean, the way you see queue, it's like that only. So what a producer does is, producer drops, okay, a message on the MQ, right, in the message queue, and consumer picks up the message from here. Okay, so this is a very simple way in which I can describe the entire specification which is built around the messaging queue part. Okay, this is how it has to work. Now let's go below and see the type of the messaging model which are there in the market today. So one is point to point, okay, and one is publisher subscriber. Publisher subscriber. So point to point is nothing but I mean, it's basically like you have one producer and one consumer. So you send it to one place, and then there is a consumer on the other hand which is listening to that particular message. It grabs it and starts working on it. Okay, so this is point to point. What happens in the case of publisher subscriber is that there is one publisher, one particular system which is one particular producer which is producing the message, and then there are multiple consumers, and all these consumers are like listen to that particular message and have the option of downloading that particular message, right? So here in this the example which I was giving was a typical example of point to point. So what happens here is that producer, as soon as it drops a message on the MQ, this message, I mean, we can either like say only read it, like say browse it. So in this case it is not removed from the queue, or even if we like read it properly, it gets removed from the queue. And if it gets removed from the queue, I mean, no one else can read it. But typically in this configuration, you have one producer for a message which sends a message on one particular MQ, and on that particular MQ we have one particular receiver which we call as consumer, which receives this message. So there is one-to-one mapping, this point-to-point mapping. But in the case of subscriber publisher model, right, but in the case of subscriber publisher model, we have a subscriber. I mean, you can have like say publisher. Publisher is like say one producer. So producer is always one. Okay, in this particular case, but there can be many subscribers. The subscribers can be many. So here, once you produce a message and send that message, you can have like say thousands of subscribers waiting for that message, and they all get notified and they all can work on it, right? It's not that like say there has to be one-to-one mapping. Now again, if you think from practical perspective, both of them have its own advantages, right? So say if you want to develop a system where you want to keep the mainframe system, and I'm just giving an example, right? And there are thousands of possibilities using these message-oriented middleware systems. So say if you have application from where you are sending this message, the mainframe system, and there is a Java application on the other hand which is listening to this message. So if that is the case, you're sending this message, then if this message is out there, and if you have like say you want to create a customer, so you want to create a customer, that's fine. You say you have one-to-one mapping, right? You send a message. On the other hand, you have a receiver. But there can be a case where you don't have one-to-one mapping, right? You want to it's an event-oriented architecture. If an event happens, you want to involve all the things which are all the systems which should get affected by it, right? Like say if the customer details gets changed, and you are the only system which knows about this change, But there are other systems, like say there is a separate system which maintains account information for that customer, and I'm typically talking with respect to the bank in place. So if you have this banking system and you have multiple departments, and one department is dealing only with the customer information, the core customer information, and there are different banking environments. Some of it deals with the account information, some deals with only the transactions part, etc., etc. If that is the case, and they all needs to be notified of the core customer data. Maybe not all the gory details or related to the customer, but if some core data has changed, like say first name, last name, etc., or maybe the customer ID, for whatever reasons, it needs to be the other systems also needs to be informed. So if that is the case, then you send a message to all the systems. So in this case, you have one producer, but the subscribers are many. All the departments have their own application, and they're all listening to it. So it's a kind of publisher-subscriber model which is required here. So keeping that, and here the message which you send, I mean it's called. I mean here the wherever you like the message you send is called as topic, right? Because it has many subscribers, so it's called as topic. So anyways, let's go ahead and see what's like what we've written here, and then we'll like move forward. So point to point in the PTP diagram, the point to point domain or application has three primary components like message queues, senders, and receivers. Each message is addressed to a specific queue, and receiving clients extract the messages from the queue established to hold their messages. Queues retain all the messages sent to them until the messages are consumed or enter the message time slot. So this is what exactly we discussed, and this diagram basically shows that, right? So messages are coming, you have a message queue which holds onto that message, and then on the other hand you have a receiver which reads messages from there, and you have the option of only browsing the messages, or you can like say read the message and remove it from the queue. There are various options, various ways in which you can get the messages from there. Okay, so this is the case of point-to-point messaging. In the case of publisher-subscriber model, the client's address messages to a topic. So here you do not have queues, right? So queues is basically like first in, first out. So you only have one-to-one mapping here. So this is called point-to-point. But in a typical environment, if you have like say one producers and many consumers, so it's a publisher-subscriber model, and in that case you have the place where the messages are held. That's not called as message queue, it is called as topic. Okay, so publisher subscribers are generally anonymous and can dynamically publish or subscribe to the content hierarchy, right? So publisher publishes the message on a topic, right? And there are many subscribers which are subscribed to that topic, right? So it's a kind of newsletter concept. So they're all subscribed to that particular topic, and whenever a message comes in that topic, they are notified of it, right? So they are notified of it, and they can start working on it. But none of them, if they work on it, the messages will never get removed. So publishers and subscribers are generally anonymous and can dynamically publish or subscribe to the content hierarchy. Topics retain messages only as long as it takes to distribute them to current subscribers. So if all the current subscribers have had a copy, it will get removed. But unless all of them read it, it will still be there. Okay. You see, everything is same. Only thing is that you are publishing a message, and there are multiple subscribers for that particular message. And then again, there are some core differences which I think is clear by now, but let's anyways go through it. One is that each message has only one consumer in the case of point to point, but in publisher subscriber you can have multiple consumers, right? And in case of point to point, messages are first sent to the queue. Here the messages are sent to the topic, right? So there's no difference. One is that there's just a terminology difference. One is a case of in one case the messages are sent on the queue. In the other case they are sent on the topic. Now the third is a sender and receiver of a message have no timing dependencies. The receiver can fetch the message whether or not it was running when the client sent the message. This is in the case of point to point, and this is a typical example of asynchronous messaging. In the case of publisher subscribers, they have a timing dependency. A client that subscribes to a topic can consume only messages published after the client has created a subscription, and the subscriber must continue to be active in order for it to consume the message. So obviously, if it is not active at that particular point of time, it's not going to get the message. So as long as the topic tries to distribute the messages, and it has done the distribution from its part. If the subscriber is not active, I mean, it's not, it doesn't worry about it. I mean, it's, the task is considered as closed. The receiver acknowledges the successful processing of a message. In the case of point to point, in the publisher subscriber, there is no acknowledgement. And they send the message, and then the other party is receiving it. There is no, I mean, you will never be able to know properly whether your messages has been received or not. And I mean, and there is nothing wrong in the way it has been done. It's typically because, I mean, here you have many subscribers, so you do not know how to send that acknowledgement back. So that might be one of the drivers behind coming up with this kind of architecture, right? Now, typical uses of JMS in enterprise solutions, there are many uses, right? So one is that if you want to create customer, you use point to point. If you want to update customer details in multiple systems, you go for publisher subscriber model. So there are multiple ways in which this can be done, right? So again, let's see what all is here. So one is JMS is useful where there might be requirement for pushing data to the consumers. Example, bulletin board, news updates, stock quotes, auction websites, and here you will use publisher subscriber. Okay, so the whole world is all about collaboration. Businesses and applications can interact with each other via messages, as JMS will allow them to integrate with each other without tight coupling. So these are the typical solutions which I was talking about. So I'll wait for a second, right, and I'll ask if you guys have understood or not. Have you guys understood? Okay. So let's move ahead. Now, what I will take a small break here